Okay, so good evening, everyone. Welcome to Programming with Python 2. We're just going to start, and I hope they will join us really, really soon before we go deep into the class. So today we're going to go into Programming with Python Part 2. And last week, we discussed fundamentals of programming. We looked at functions, variables, what programs do. We looked at operators. We looked at data types, and then the core programming construct. So in the absence of any question, we're going to move on with today's class. So like I said initially, we are going to discuss programming with Python 2. Now, my name is James Inalegu. I am a software developer with Maxify, for those who don't know. Also, in today's module, we're going to be discussing quite some interesting topics. First, we're going to be discussing structured programming, understanding how our programs are supposed to be structured. Then we're also going to look at data structures in Python. Data structure is just simply how you organize your data in a more complex environment so that you can be able to write real-world code. Then we're going to be looking at object-oriented programming. So essentially, object-oriented programming has to do with, it's a programming thinking, is a paradigm that deals with objects, how computers understand the world. Now, aside from object programming, oriented programming, we have functional programming, we have procedural programming. But in this session, we're going to be looking at object-oriented programming. Then after that, we're going to move on to APIs in Python. Everything is an API. All the language constructs is an API. So we're going to take a very brief introduction into APIs so that we understand what they are and what they do, how we use them. Next, we're going to be understanding Git and GitHub. I know some of us have some basic understanding about GitHub from the installations we made for last week's session. But for those who don't know, or it's just going to be a kind of like a refresher into Git and GitHub. Then we're also going to be looking at web development with Python. And lastly, we'll look at the Magic Django framework. Now, the requirement for today's class is going to be very simple. I'm going to drop a link. So we're going to be using Screenbar. Screenbar is an online interactive coding tool. I just dropped the link. So click the link and open the Screenbar website. We're going to be using it to do live coding and interactions. So just while I'm talking, before we go over to Screenbar, we'll need us to just register and create an account. Then I'll come back to that subsequently, because we're going to be doing some live class assignments and we're going to need Screenbar to code in real time. Okay. So that's the requirement for today's class. So without further ado, I would like to jump into each of these lessons in today's module. First, we'll start with structured programming. And the way it's going to work is I'm going to explain some basic theories, and then we move to coding where necessary, right? We're going to code and then also go into the theoretical section. We'll keep switching context. Then we're going to be having class works at the end of certain lessons. Then over time, we're also going to be having some 5 to 10 minutes break. So let's just jump into today's. So structured programming. Structured programming is a concept that was formalized in 1966. It's just a theoretical computer program design using sequence, decision, and iteration. So essentially, what's help our to be structured in a better way. As new beginners, most times when we try to write programs, we typically do not know how to start or how to go about our code in a more logical way. So these three things, talking about sequences, decisions, and iterations, essentially has everything you need to write your program. All programs in the world compose of these three things. And then, like I said, structured programming is a software development method that uses modularization and structured design. Large programs are broken down into small modules, and each individual module uses structured code. So normally, the way it works is you structure your code using these sequences, right? Now, what is an algorithm? I'm going to come back to the three sequences I mentioned, the three components of structured programming as I mentioned initially. But before then, let's talk about algorithm. An algorithm essentially is a procedure or set of instructions for solving problem in terms of actions and then in terms of order. So when you want to write programs, you first of all need to understand the problem you're trying to solve. And in trying to understand the problem you're trying to solve, you will have a goal in mind. So that goal enables you to now write down each of the steps, the sequences, the step-by-step action you need to take, and then the order at which you need to take those actions in order to achieve that problem or solve that programming challenge. So algorithm essentially is just a procedure or set of instructions for solving a problem. And there are two major things you need to understand: that there are definite sequences, actions you need to take, and then in certain order. If the orders are not in place, then your program will not work properly, because computers really can be dumb sometimes. So they need to understand clearly what all the actions they need to take are, and then the order at which they need to take the action. So three basic control structures. One, we have, like I said initially, we have the sequence structure. Sequence structures essentially are ordered statements or subroutines executed in sequences. They are ordered statements, right? When you run your code is supposed to, or your program is supposed to run step by step, one line at a time. So sequence structures, essentially what they do is they allow you write your program step by step, one line at a time, because that's how even the Python interpreter understands your code. It reads it statement by statement, line by line. So the first fundamental thing you need to understand about structured programming is, one, we have sequence. The sequence structure simply states that you have to run your program step by step. So anytime you're writing your program, you must bear that in mind, that it has to go step by step, one line at a time. Then two, we have selection structures. So typically these selection structures help us make certain decisions, right? They help our program to make logical decisions. For example, if there is a rainfall, then I need my umbrella. Can we all hear me?
Yeah, I can hear you.
Okay. So let's move on. So the third control structure is repetition. So these repetition structures enable us to actually do certain things continuously, more than one time. Let's say we want to repeat a statement continuously based on certain condition. So this is also known as iteration. A statement or a block is executed until the program reaches a certain state. This is usually expressed with keywords such as for loop and while loop. So these are the three basic control structures we have in programming, and they help us to structure our code. First, we have sequence. Two, we have selection. This enables us to make decisions. Then three, we have repetition. Now,
sorry, James. We have people sending messages in the group. They want to join. They are the lobby. I don't know if you can see them. Okay, we have Wale. Okay, Wale is here. I think someone else wanted to join. And maybe you just transfer the host to Shima so that he can be letting these guys in so you don't get broken. Your flow doesn't get disrupted.
And then please try to align your screen to your right because your face is reading out of the screen. To your right.
Okay.
As far right to. No, you should come more. Adjust more.
It's fine.
Okay, I think this is fine.
It's fine. All right. Sorry.
Yeah, right now there's nobody in the waiting room.
Okay.
Trying to transfer. Okay, so can we continue?
Yeah, I am.
Okay, fine. So let's move on. So at this point, let's try to log into Screenbar. Let's create an account on Screenbar and do a basic so that we can write some code. So when you log into Screenbar, you just create a new screen. Yeah, I have the link in the chat room already. You can just click and create an account. Once you create an account, then I'll send you a link. Let me drop the link so that we can have access to what I'm doing over here. So have we all created the Streamer account? I just sent a link to my live coding terminal.
Yes, I've created the account.
Okay, awesome. Just log in. Once you log in, copy this link in the chat room and then try to so are we there? Are we together? You can drop messages in the chat room from the same page. So copy the link, paste on your browser so that we can. So I'm going to show us an example of a sequence. So like I said, there are three kinds of control structures, right? And these are all part of structured programming paradigm. So first is the sequence. Now, a sequence is just a step-by-step instruction you write, step-by-step program you write, or instructions to your computer. So for example, if I do print hello world, this is a sequence. and then I come down and then I do another print. Print my name. So these are step-by-step instructions I'm giving to my computer to run on my behalf. I can also declare a variable called, for example, my school, and set this to unijust. So these are step-by-step instructions. This is an example of a sequence structure. All the codes are written line by line. And then I can decide to run this code. So let me run my school. Now, if I run this code, at the terminal, you see hello world, James, unijust, right? So the print statement, what it actually does is it outputs whatever you pass into it, either strings or numbers, whatever data you pass into the print function, it outputs it into your terminal. So we have hello James, hello world, James, and unijust. So this is an example of a sequence structure. Okay, this is the simplest structure, of all the three fundamental control structures we have in programming. Okay, can we move on now? Are we seeing my screen?
Yeah, I can see your screen.
All right, fine. So I need us to change my code. I need us to change my code. The task is to calculate the area of the rectangle. So this task is very simple. We just want to explain what another example of what sequence structure does. So we are going to calculate the area of a triangle. Now, the formula for that is the area is base times height. So the formula for calculating the area of a triangle is base times height. So for example, let's declare a variable called base, give it a number 10, and then height of 20. So this is declaring a variable, assigning the number type 10 and number type 20 into base and height variable. Now, for us to get the area, we can now say area equals to base times height. Okay, Wally, you want to say something?
Yeah, it's actually half base times height. So when I'm hearing base times height, it's giving me, it's half base times height. So yeah, just to make that correction.
Yeah, that's correct. The area of a rectangle
of a triangle.
This
one is for rectangle, but the triangle is half base times height. Yeah,
this is rectangle, so it's base times height.
This is rectangle is base times height.
Yeah, it's triangle that is half base.
So we're trying to calculate this. We can now do print area. So essentially, this is just sequence structure. All our code, we're just trying to identify, write them statement by statement, right? So I need us to edit this code. You can edit my code, change the value for base and height. You can use whatever value you want. Just change the value and run print. Let's see what you have. Okay, I have 200 when I run my code. So what do you have? You can change the value, just interactively enter into the live terminal, change the value, and then print the area. Are we done?
Yes.
Okay. So this diagram essentially just explains what I said. For focus on the green diagram, we have statement, statement, statement. So this green, the first green diagram just talks about sequence structure, while the second green diagram talks about conditionals. And then the third talks about loops. Okay, let's move on quickly. Okay, now let's talk about conditionals. So conditionals are essentially operators. They allow programs to make decisions as if your program has the choice between taking the left road or the right road. We discussed some of these operators last week. So these conditionals, essentially what they do is they help us write, help our programs make decisions, okay? So we have the equality operator, we have the not equal to, we have the greater than, we have the less than, we have the greater equals, and then we have the less than equal. So all these operators are conditional operators, right? And they actually help us in our second control structure, which is selection. Now, next we have the if statement. If statement, from my slide here, you can see is just, this is the syntax for if statement. If a condition is true, then this block of code is going to run. So essentially, if statement, they use booleans, true or false, to decide whether or not to execute. If the statement x is greater than y is true, then the compiler will register it as true and execute the code. So whatever this first line of statement evaluates to, either true or false, that's what's going to determine if the next line of code is run. So if the condition is true, the code block will run. If it's false, then the code block would not run. So let's quickly do a demo. If 5 is greater than 6, so this code is not going to run. It's not going to print yes, because 5 is not greater than 6. So let's run it anyway and see. You can see the last print statement was the area, so it's not going to run. But if 5 is greater than 4, which will evaluate to true, then the print statement is going to run. So we have yes now in the console. Next, we have else and elif. So this is another type of conditional statement that uses more keywords, the elif keyword and then the else keyword. The if condition is true ever runs. If it's false, another block of code will run. And then if that condition is false, it will skip and then go to else statement. So the if elif else condition is just to check whatever evaluates to true is what is going to run. If the first and the second condition evaluates to false, it means that the last else statement is what is going to actually get executed in our code. So let's quickly move on to repetition. Do we have any question?
None at the moment.
Okay, so repetition structure, essentially, what they do is they help us to make, to essentially run a statement multiple times, right? So this is a control structure that allows the execution of a block of code or block of statement multiple times until a specified condition is met. It is also known as an iteration control structure or repetition control structure. Programmers are typically lazy. Let's say you want to write 1 to 100. A non-programmer will just write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 down to 100. But a programmer will simply use a construct called loop, either for loop or while loop, to actually write 1 to 100 without essentially write 1, 2, 3. So repetition structures are essentially supposed to allow us run a particular block of code multiple times. Okay, so it is not efficient for us to keep printing. For example, I might have 3 print statements. So I have 3 print statements here. When I run this code, it's going to output all the 3 numbers, but this is not efficient. So we need a mechanism like loop to help us run this thing. We'll just write the statement once and then loop takes over. So that's why we need the repetitive control structure, right? So like I said, essentially loops are a way to do something over and over and over in Python. They come in 2 main flavors. We have while loops, and then we have the for loops. But let's take a quick look at while loop. Now, this is the syntax for a while loop. While a condition is true, then the following block of code we run. So let's say we have 5 greater than 3, then this particular block of code will run. But if it's false, then this particular block of code will not run, right? But the difference between a while loop and an if statement is that a while loop will continue to run the block of code continuously until the condition becomes false. So we have to be very careful in order to make our program not to crash. If you write a while loop, I've been in that condition before where I wrote a while loop and then I forgot to ensure that the condition resolved to false at certain points. So, and then the program continues to run over and over and over until I had to shut down the system and then restart the program. So we have to be very careful when writing loops because they can make our programs crash. So when you have a condition, you have to find a mechanism to make sure that the condition evaluates to false. So let's take a quick example of a while loop. So now I have, for example, I have I equals to 1. This is my counter variable, and then let me declare a while loop. So what this code is doing is checking a condition that while I is less than 3, initially I is a counter that is equals to 1. So at this point, I is 1, right? We assign the value 1, the number value 1 into a variable called I, or index. You can call it index. So as long as 1 is less than 3, this block of code should continue to run. Okay, this block of code should continue to run. Now, from the code, we know that 1 is definitely less than 3. So if you run this code the way it is now, your program is going to break. You need to find a way to change the condition. If not, it will run infinitely, and then it will affect your program. So we need to have a measure to ensure that that condition changes to false. And that's what this third line of code is doing. So we're going to define So what I just did now, the third statement is just to increment I, so that at some point I will be less than or equals to 3. So at the first instance, I is 1. When it runs again, I becomes 2, and then the third time I becomes 3. At that point, the condition evaluates to false, and then our program will stop. But if we don't have this mechanism in place, it means our program will continue to run till infinity. So let's try and run this program and see what happens in the console. So if you look at the console, we have meow 3 times, no? So this is how to run a while loop in Python. So let's look at this diagram. It just helps us illustrate what while loop does. First, the program starts, we initiate a counter. This counter is supposed to help us change the condition at a certain point. So as long as I is less than or equals to 3, the code will continue to run. So if it falls, then the code will stop. Essentially, that's what this diagram is talking about. Then the for loop is similar to the while loop, but the syntax are different. So they are used to iterate over sequences of elements, performing some block of code for each element in the sequence. Now, for loops are very important because they work with lists. From the syntax, you can see that for item in iterable, the item represents every item in an iterable, and iterable can be a list of names. So for loops helps you go over a list and then print item in that list, right? You don't have to do it manually. So the for loop knows how to do it. It goes through all your lists and then outputs certain blocks of code. So this is the syntax for while loop. And this diagram tries to explain what while loop does. So I'm going to actually start by creating my list. My list is going to be an array, 1, 2, 3. It's going to be a list of numbers, 1 to 3, right? Stored into this variable called my list. Now, let's remember the syntax. It says for every item in an iterable. So in this context now, we can create a while loop to say for every item in my list. So we can have this. So what this block of code will do is to print out all the items in the list. So it does that repeatedly. Let's try to run the code. Okay, I have a syntax error. Okay. All right. Yes, so we have 1, 2, 3 printed out in the console. So let's quickly move on to the next. So we have a class exercise now. In this case, we're going to share our screen so that I can see our code. So it's going to be a simple grading system. So we're going to have a simple grading system. We're going to write a program that prompts a user to impute a student's score, then use if and else statement to determine and print the grade. So this is the question. Yes, Hassan. Hussein, sorry.
Good evening, sir. Hello?
And I can't hear you.
Okay. Can you hear me now?
Yes.
Okay. So, but I was still having issues about that Anaconda. I have been running it several times, but up till now, I have not been able to run the Jupyter lab.
Okay, don't worry about Anaconda for now. Just check the chat room. You will see a screen bar link. Click on the link. Okay, click on the link and create an account quickly. And you can, I've also shared the screen. I've shared my screen.
Okay, the
You can
WhatsApp
see
link.
live, and then you can also edit code real time. So just go to screenbar.com, create an account quickly if you've not done that, and then copy the link I just sent in the chat, and then you can continue from there. So this is a simple grading system task I want us to write. So we're going to write a program that prompts a user to impute a student score, then use if-else statements to determine and then print the grade based on the following grading criteria. So the hint is very simple. What we're going to do is very simple. It's just to have a variable, maybe score. That variable is going to essentially get get a particular number. Then you can now run if and else clauses to see if what grade the student has and then print it. It's a very, very simple program. So let's try it out. If you have any question, just let me know. Also, you're going to use a Python function called impute. First, before I continue, did we go over some materials I sent over the weekend? Because I might not have enough time to go over some basic, go into details on some basic stuff. Like this input function, what it does essentially is to get an input from the user in the console. So when you use it in your program, you can typically get whatever input or data from. Remember, I told us we can get data from the terminal or the console. So the input function is a way to get input from the terminal. Okay, so we can use it, get input, store it into a variable called score. Once we've done that, then we can actually check if the grade is 90 and above using if statement, then we can print the grade. If it's 80 to 89, we'll print B. If it's 70 to 79, we'll print C. So that's how we run the program. You can just try it out and let's see before we move on quickly. Husseini, your hands is still raised up.
Okay, okay. I'm coming.
I'm going to give us just 1 minute for this. It's a very simple program.
Are we going to write this program in this demo interface that you showed, or we're going to write it in a new interface?
Sorry?
Right. Are we going to write your code that is already existing in this current interface?
Write the code in the screen, yes, I can, so that I can see it live. But just use comment to put your name so that I'll know who's writing what. You can just click on the link and edit my code instantly.
Okay.
So you're going to write it in this demo.py file. Use comments to just write in your name before you write the program and then save. Okay, let's just continue now so that how many of us are done with the coding challenge? You can just write in the chat room. You have more time. Okay, I'm just going to copy the solution. So this is the solution. Comment out this code. So this is the solution. Essentially, what we're doing here is just simple. First, we define a variable called score, and then we use the input function to get a score. When we get this score, I'm going to run the code so that we see how it works. When we get this score, we'll store it into this score variable, right? Now, what this float function is doing is essentially to convert whatever input we get from this input function into a floating type, maybe 10.2 or whatever. Now, we store it in a score variable, and then we use it to check. So we are using our if condition, right? If what we enter, the score is greater or equals to 90, we print A. If it's 80, if it's less than equals to 80, if it is less than equals to 80 or 89, we print B. And then if it's between 70 to 79, we print C and vice versa. So if I run the code, so you might not see the prompt in your screen, but it's just prompted me now to put in a number. So I'm going to put in, okay, I just put in 60. So it printed D to the console. If you look at the console, it printed D. You can refresh your console to see my code if it's not showing over there. So this is just a basic example of if and else statements, right? Making decisions in your program. So let's quickly move on to data structures. So who can tell me what data structure is? Anybody? Data structures. Okay, nobody? So data structure is a collection of data values, the relationship among them, and the methods that can be applied to the data. They are also known as complex data type. Last week, we discussed simple data type. And this week, we are looking at complex data types, right? These are just collection of data and then the methods that can be applied to this data. So if you have a variable, it's just a simple data structure. But what happens when you have like 5 to 10 variables? You can actually collect them together and form a complex data structure. Okay, so it's just a way we structure our data. It's just a collection of data, and these data structures have methods, have functions. We can run operations on all of these data structures. Now, complex data structure. One, we have Python lists, we have dictionaries, and then we have tuples. These are the three complex data types we're going to be looking at today. So list, this is how to define a list. A list essentially is a collection of items in an ordered way. They are ordered and they are not, they can be muted, they are mutable as well. You can change them. So like I said, a Python list allows you to store any variable types, right? We create a list using square brackets and comma as shown below. We can print an entire list or some individual elements. We can also add elements to list using list method. So this is an example of a list. You have a variable called my list, and then you use the bracket symbol as to define your list to enclose your item, right? So let's move to list method now. First one is append. Let's quickly jump back to the terminal and do some demo. So let's say we have my list, which is a list of, let's say, numbers 1, 2, 3. Okay. So this is a list in Python. What we can do is that we can run method on this list, right? For example, we can say my list so this method essentially adds a number to the list. So if we print the list, we're going to get the new array now. We're going to get the new list. Okay, so we now have 1, 2, 3, 4 as the new list. So the append method, essentially, what it does is that it adds an element to the end of the list, as we can see. Then we have the pop method. So this method essentially takes away an element, the last element from the list. It removes and returns the last element of the list. Then we also have another method known as sort. So what this method does is essentially it sorts the list in an ascending order. So let's quickly look at another example. Let's say I have an unordered list. I can actually run my list dot sort. And when I call the sort function, so essentially all these methods, the append method, this pop method, the sort method, they are actually functions, but because they are associated with a list, we usually call them method. So this method help us run certain operations. Now, depending on the complex data type, either dictionaries, lists, or tuples, we have different methods based on the data structure. You can't use certain methods on certain data structures because they might not work. So, but you can run sort on a list, and what it's going to do is that it's going to arrange this list in an ascending order. So let me print my list so we can see what the method does. Okay, now, so we have 1, 2, 4, 6, 7, 20. The array initially, sorry, the list initially is unordered, right? It's scattered. But right now, when I run the sort method on it, it has helped us arrange the list. So essentially, Python list has so many methods. We might not be able to cover all of those methods because of time. So let's quickly move on to the next data structure. We have tuples, right? Tuples, like you can see from my screen, uses brackets, okay? So tuples are generally used when you need to store just 2 or more values together, such as X and Y values for a point. Okay, so this is how we declare a tuple. So another example, so let's move on to tuple method. Now we have the index method, we have the count method, and then we have the length method. For the index method of a tuple, when you run the index method on a tuple, for example, it returns the index of the first occurrence of a specified value. Then the count method returns the number of times a specified value occurs in a tuple. So let's quickly use this count as an example. So let's create my tuple variable rather, and then using the tuple syntax, let's 1, 2, let's add some items, 3, so if I run my tuple.count method, let's say I pass in 2 as an argument, what it's going to do is it's going to tell me the number of times I have 2 as an occurrence. Supposed to store the value because it returns a number, so I'm supposed to store it in a variable. So when I do my tuple, when I pass in that return value into this index variable, and then I can now print the variable. So it returned 2. It means that 2 occurred twice. Now let me change this value to, let's say, 4. And then I run the code. You can see 4 occurred once in this tuple. So these are methods you can run on all of these data structures. In this context, we are looking at tuples. Then the length also counts how many items are in the tuple. Let's really look at dictionaries. Dictionaries essentially are keys and value pairs. Dictionary allows us to set keys and value pairs, where each key has a corresponding value. Just like in a dictionary, each word, which is the key, has a corresponding definition. The same way, a dictionary in Python has a key and a value pair. It's also a type of data structure. So you use curly braces as a syntax in defining dictionaries. Dictionaries also come with certain methods. It has the get method, the key method, and the update method. So let's move on to object-oriented programming. Object-oriented programming is a programming paradigm based on the concept of objects which can contain data. The data are properties and attributes. This data also has methods you can run on them. Like I said, OOP is a programming paradigm. You can combine data and functionality and enclose them inside something called an object. It's a very popular programming paradigm. If you want to build complex web application, you have to understand what object-oriented programming means. Python has a built-in support for object-oriented programming. Using object-oriented programming techniques enables you to maintain your code more easily and write code that can easily be used by others. So this is just a programming style, is a concept, is a paradigm, where you declare objects, and then these objects have properties, they have attributes, and then they have methods. Now, the methods are essentially supposed to help you manipulate the attributes or the properties of that object. We're going to see more in the subsequent class. So computers only see and understand data. Computers only understand data, and so programmers have to create models of the world using data. A practical example is computers they don't understand what a house is. They don't know what, when you say a person, they don't even know what a person is. They don't even know what a car is. So because computers only see and understand data, programmers have to find a way to model the world in a way that computers will actually understand. And that's only through using data. So because computers only see and understand data. So example of a model is a car, like I said initially, a person. These are all models, and we can model these things using data. So a human being, it is clear what kind of real-world object each one represents, but not to a computer. A human being knows when he sees a car, he knows a car, but computers do not. So computers only understand data. So that's why we model all these objects as data. Classes and objects in Python. Now let's move on. Do you have any questions so far?
No, we're good.
Okay. So classes and objects in Python. I'm going to give us an analogy. Imagine a car. How can you describe a specific car? It has some attributes such as brand, the model, the color, and then the license plate. Also, there are some actions this car can perform or can be performed on it. So now classes in Python, is just a blueprint, right? It's just a template for us to create an object. I will explain more. In object-oriented programming, a car, for example, can be an object with specific attributes and then with methods, right? So obviously, you may now be asking, how can I create objects in the first place? The answer is simple. All you need is a class. So a class is just a blueprint for us to create objects in programming. So we're going to look deeper into classes and objects, how to create them. So a Python class, this is how to create a Python class. A Python class, you just use the keyword class and then you write the name of the class. In this case, we're looking at a car. A car is a class in Python, right? Is a class in Python. And this class of a car is just a blueprint for us to create multiple cars. this class car is not the car in itself. It's just a template, like a mold. If you want to, let's say, mold a block, for example, you need the mold, to pour in the mixtures of your cement and all for you to form a block. So a class is just like that. It's a blueprint, right, for us to create object. And this is how to define a class. You use the keyword class, and then you pass in. So this part here, essentially, what it does is just to allow me, for the meantime, let me define a class. So I need to use the keyword class car. So this is how to define a class. Now, there are other things I need to write in this block of code, but for now, I'm just going to use the keyword pass. This is just going to allow me leave this class like that without errors, to say that, okay, I'm done declaring it for now, but I'm going to come back and add more things inside the class. So this is how to define a class in Python programming, right? So a class, like I said, is a template or a blueprint for creating objects with specific attributes and behavior. You can model almost anything using a class. So this car, for example, this is an example of a class. Now, a class, if you look at this car, it just represents a class. It has attributes. The fields such as brand, model, color, license plate is an example of attributes and properties. While the actions we can perform on this car is to turn it on, turn it off, and accelerate. So if we define this class, we can now create multiple objects of this class called car, multiple instances of them, and then they can now have all of these attributes and method, okay? So I just defined a class, but that's not all. A class also has another thing called the initializer. This is like a constructor. If you are defining a class, you must use this initializer. It's a function, it's a special function in Python called __init __. Now, this function, what it does is, if you define it inside a class, it helps you create an instance automatically. By the time you want to create that class, that car object, it allows you to create an instance. So you have to define the properties of that class using this function. Okay, so the function, essentially what it does is, it's the constructor. It helps us construct this class, and then we can now create multiple cars objects with this class. Okay, so I don't know if anyone has any question on this before I move on. You can drop in a chat.
Okay, sir.
So let's look at class instance. So this is how to create an instance. So now, after defining our class object, we can create an instance of that class using my car as an example. So this my car is a variable. This my car is just to create an instance of that class we defined. Now, I need to pass in the arguments, the name. For example, if you look at what we did initially, we said this class is going to have, it has this init method that defines the make of the car, the model of the car, and then the color of the car, right? So that is what, so if we're calling the class, the car now, we have to pass in all of these arguments. This is the first one is the make, which is Toyota. The model is 2015, and then the color is black. So by so doing, we've created an instance of this car inside this variable now. So what we can now do is we can get data about this car that we just created. I can create multiple cars from this car instance as it is now, because by passing different data into the car and class, I can create multiple copies of that car, so, and then I can do certain things. I can manipulate the data. For example, I can print the car's name, I can print the color, I can print out the model, all these things because I've declared it when I called the class. When I called the instance of the class, I actually declared it. Then let's move on to class method. There are different kind of methods. Classes also have methods in them. So you can write methods inside of a class. For example, this first method is to turn on. So this, for example, if you have a car, you can turn on the car, you can turn off the car, you can also accelerate, you can change gears and all. So these are all methods of a class. They essentially help you to manipulate the data in a class object. So when you declare a class, create an instance of a class, that class usually has attributes. So it is these class methods that perform operation on all of those attributes. Okay? So sometimes we want to add functionality to a class itself. So class method they can be used to add functionality to a class. So after we create a class instance, we can also create method for the car and then use dots to call any method. So if I want to call any of these methods, I can simply just say my car.turn on, my car.turn off. All of these things would be invoked. Now, I want to talk about quickly another strong point when it comes to object-oriented programming, which is encapsulation. Encapsulation is the bundling of data and method that operates on the data, okay, in a single unit. That is a class. It restricts access to some of the object components and prevents direct modification. Let me explain what this means. Encapsulation essentially, let me give this analogy. When you drive a car, let's say you bought a car and then you're learning to drive, you don't necessarily need to understand how the lighting system or the gear system or the brake system works. You don't really need to understand all of those things, but you know that when you turn on the car and apply your brake, it stops. Or when you accelerate the car, change your gears, all of this functionality seems to work, but you don't really necessarily, you don't really have to know how they work under the hood. You don't really need to know how the engines work. So that's the same principles with objects. I can define a class, I can declare a class, create multiple objects within that class, for example, a car, then I can have methods. Now, encapsulation essentially means that the object has all its data and its method. The method are the workings, are the functionalities, are the operations that on those data in the object. So you don't really need to know how some of those objects work, except if you define the class. Because as we move on, we're going to be using some third-party classes. We're going to be creating our own objects from other people's classes. But the principle of encapsulation helps us to really use these classes without understanding how they work under the hood. You don't need to know. It's called information hiding. So I can declare a method, and then that method performs certain operations. All you need to do is to call the method and use. You don't really need to know how it works. So that is what the principle of encapsulation entails, right? Then we have inheritance. Sorry? You can just drop in the chat box. I didn't hear you. Okay, let's move on. So next we have inheritance. Inheritance is perhaps the most powerful feature of object-oriented programming. Inheritance is a mechanism whereby a class can inherit features, data, methods of other classes. Okay, so inheritance essentially is a mechanism in which a new class inherits properties and behavior from an existing class. I won't be able to show us code slides because of time. Trying to rush up. Then let's quickly talk about modules. Modules in Python is just a Python file. It's just a file with a .py extension. In reality, they are a way to organize function classes, okay, and variables in one or more files. Modules help us to manage, reuse our code across different modules and extend as the program becomes complex. So when you write a .py file, for example, here I have demo.py. This file is called a Python module. So it's just a module, and then inside a module, I can define a class, I can define variables, I can define function. So it's just a way for us to organize our code, really. Essentially, that's what they do. It's just a Python file. So advantages of a module is for simplicity, maintainability, and reusability. So creating a module is just as simple as creating a .py extension file. It's not difficult. We've done that. Then let me quickly discuss about Python packages. Now, a Python package is a collection of modules. So when you have different classes in a module or in a Python file, and then you create other modules, let's say you have multiple modules, which are files bundled together, they can form a package. So it's just a directory or a folder of different Python files. So a Python package essentially, like I said initially, is just a collection of different modules, right? Put together, bundled together to make a package. Then you can import a file. There are import statements. When you have a module, you can import modules from other files into your current directory, right? So that's how there are two kinds of import statements in Python. First import statement is let me just quickly show you an example of import statement in Python. So essentially, when you have two files, you can import functionalities from one file into another. So for example, now you can just do import the module here is just a file name. So let's say I'm in demo file. Let's say I create another module here. Trying to create. So I have this new Python file called app.py. I can just define a function. So now this is a Python module, right? It just has one function here. Now I can define this function here and then not use it. Okay, I can then import it into this demo.py file. I can just say, if using this syntax, I can say import the module name, which is, I change this now.
Sorry, we can't see your screen.
Sorry?
We can't see your screen.
Sorry about that. So I defined an app.py file trying to explain the concept of modules and packages. So this is a module, right? Any file with a .py extension is actually a module in Python. And then you can have different collections of these files, bundled together to form a package. So I want to show us how to import this app.py file into this demo .py file. So it's very simple. Just use the import statement. So now I've just did an import. I can now call this function that I defined here. And I'll call it so if I call this function now and run it, so seems to be getting an error. Okay. So it's telling me that I can't actually use that names. In a second. Okay, for some reason, it's not showing an error, but essentially these are the two ways, the two syntax. Maybe the screen bar is not recognizing these files. So you do import the file name as you can give it your own custom name, or you say from that app or that module, import my name. I actually have a function here called my name, but for some reason it's not. I don't know, it's not recognizing it. So this is how you import functions, import modules into your file through the import statement. First, import the app you want to, the name of the app or the module as whatever you want to call it, or you do from this app name, app.py, import my name. My name. My name is actually a function here. So that's why I'm calling it, So that's how it works. So at this point, we just take a 5-minute break. And then we'll come back to continue from where we stop. If you have any question from what we've discussed so far, you can drop it at the comments, at the chat box rather. If you have any question, you can drop it at the chat box. Let's just go on a 5-minute break, then we'll continue. So we're going to be looking at, we're going to continue. There's no any question. There's no question for now. We're going to just continue with the next lesson. So pretty much, we're going to be talking about APIs in Python programming. So API stands for Application Programming Interface. It's just simply some rules, on how we can interact with other people's code. Now, it's a very, very important concept in web development, especially backend web development, because most of the times we'll be consuming APIs, other people's code. For instance, if we want to integrate payments, maybe collect payment from customers, we would have to request for a payment system API, right? So let's say we want to do Stripe integration into our web application. We would need to go to their website and integrate via their API. So application programming interface is very, very important. Everything essentially is an API. Even your functions, your methods that are built into every programming language, they are called the language APIs, right? So APIs are very, very important in programming. So an API is a set of rules, protocols, and tools that allows different software applications to communicate with each other. APIs define how software components should interact, providing a structured way for developers to access functionalities or data from other software. So let's say you want to use a particular library, maybe a data science library, pandas, for example. You have to go to the documentation to study about how to use their classes, their methods, their function. Now, what you're doing essentially is basically studying to understand how their API works, how those custom functions really work in order for you to use them in your data analysis job. Similarly for web applications, right? There are a lot of packages that have been built, a lot of libraries that have been built, for us to use. So let's move on. Types of APIs. So types of APIs. We have internal APIs. These are the built-in APIs that come with every programming language. Things like operators, functions, methods, classes. All these things are APIs. Okay, they come built-in. In Python, we call certain things standard Python libraries, standard functions. These are built in. They are all internal examples of internal APIs. The print statement, the input statement, the sort, even methods we run on data structures. These are all internal examples of internal APIs, and they are built into every programming language. So we have external APIs. These are libraries and frameworks. A library is a collection of pre-written code that provide functionality for specific tasks or domains. Library typically offers APIs that developers can use, can access in order to access certain functionality. So the essence of us using external libraries or external APIs is because we want to use or make use of other people's code. We want to ensure that we have certain functionalities in our application. And one of the core principles of programming is don't repeat yourself, try. So if there's a solution for something you're trying to build out there, it's better you actually check, research, get a library or a package that actually does that job, and then you integrate it into your code using import statements, right? And then you don't really need to know how they work under the hood, you know. So similarly, frameworks are more comprehensive than libraries. Libraries are just pieces of reusable code, but a framework is much more. It's a set of tools that allow us to build softwares, right? They often expose APIs to developers to extend or customize behaviors, right? So an example of framework is Django, which we are going to go into shortly. Django, Flask, these are examples of web frameworks. They have so much inbuilt into them. They are opinionated. They tell you how to do a lot of things. You can have libraries inside of a framework. So a framework is kind of like the mother of it all, while a library can just be a part of a framework. It's just a piece of reusable code. But a library gives you A to Z, you know, APIs on how to do virtually everything about that you want to do. So frameworks are more elaborate than libraries. Then another example of external API is web APIs. Web APIs are examples like Google Map, Twitter APIs, Stripe payments, like I said, Algolia, Zoom, all of these things, all these solutions we use, software products we use every day, they have APIs built in. So they are examples of web APIs. We can, aside from libraries and frameworks, we can actually make use of web APIs. They are also external APIs. So in the course of writing our Django application, we might be leveraging on some of these APIs. For example, if you want to integrate payments in your application, you have to make use of either Paystack or Stripe. So how do you make use of Paystack? They have the infrastructure to charge a customer. So you have to integrate their API into your application, essentially. And these are web APIs. We're going to look into them. They are called RESTful APIs, actually. So let's move on quickly to the next lesson, understanding Git. This is just going to be a brief run through because it's very easy. Some of us already have understanding about Git and GitHub already. So Git is just a command line tool that will help us with version control in several different ways. It's just a tool that helps us to keep track of our changes whenever we write code. So like I said, it keeps tracks, it does that by saving snapshots of our code at every given point in time, right? So now it also synchronizes our code between different people. We can collaborate on a project using Git. Everybody is making contributions to the project. Everybody is committing to the project, right? So Git essentially is a version control system, and it's one of the best version control system for tracking your workflows. It helps you with collaboration, and it helps you to even revert to previous changes or previous code you've written. You know, so essentially, it's a fantastic tool that every developer must learn how to use. Now, I'm just going to run through some basic Git command. If you want to initialize Git, if you want to start a Git repository, or if you have your code and you want to start a Git repository, all you need to do is to say git init. Git init is a basic command that helps you to initialize a Git repository. Then we have git clone. What clone does is for you to get a copy of a remote repository. If you have a remote repository, let's say on GitHub, you can use git clone command to get a copy of it onto your local machine. Then we have git commit. We have Git push for pushing your codes to GitHub. We have Git pull to fetch changes into your local repository. We have merge and what have you. So these are all examples of Git commands. We can check more on that online if you want to. Also, GitHub. GitHub is GitHub is a website So this is the GitHub website. As you can see, let's build from here. The world's leading AI developer platform. So what GitHub helps you to do is to store your repository remotely. So if you have a code base and then you've initialized it as a GitHub repo, GitHub essentially helps you to save those changes in a remote server. Then it also helps you with collaboration with your peers. You can also see other people's code. You can explore other people's code. You can create organization. You can even host your project on GitHub. It also has Copilot. This is one interesting feature that allows you to essentially write code using AI. So this is GitHub. You can simply create an account if you've not done that already, but I believe most of us have a GitHub account already. Now, let's quickly move on to web development. First, we're going to look at internet. The internet is a global network of companies. It's a global network of computers. It was invented in the 1960s due to the convergence of computing and communication technology, right? So the World Wide Web, the internet is actually different from the web. The internet is just a global network of computers. Why do the World Wide Web allows computer users to execute web-based applications and to locate and view multimedia-based documents on almost any subject over the internet. So the internet is just like the protocol. It allows us to view the web pages essentially. So the internet is just a global network of computers, while the web is a layer on top of the internet that allows us to view web pages, any kind of web pages on the internet. The web was invented by an English computer scientist known as Tim Berners-Lee in 1989. So the web should be about 35 years old now. And then it was opened in the public in 1991. So how does the web actually work? So before, the web actually works in stages. I'm going to show us this diagram. This is an example of how the web works. First, you have a client, which is your web browser. You impute an address, technically known as a URL, into the web browser. Let's say maxifyglobal.com, and then the browser sends the request to a DNS server, and then the DNS server calls your application or your website. Your website is also run on a server. The DNS server, actually what it does is it transfers the text that has been written into an IP address, and then the IP address is going to be tagged, every website on the internet has an IP address, right? So when you put in a URL, it makes a connection to the DNS server, from the DNS server to your own website server. And then your website server accepts the incoming request, check for the resource that you've requested for, and then make a round-trip response, and then it shows you a website. Now, the website you see is being shown from a client, which is the web browser. So the web browser has the functionality to actually display pages. What is sent through back to the web browser are just templates, HTML templates. But beyond that, the server can also send other forms of data. We're going to look into that shortly. Not just HTML template, the server can send other forms of data. But in this case, the server returns a web page, which is going to be rendered in the browser. So this is essentially how the web works. First, a request is sent through the URL in the search bar, sent to the website. The website server then accepts the incoming request, search for the resources, and then send back the response to the client. So it's called a client-server communication. Now let's look at the concept of multi-tier application. In web development, there are essentially two broad categories. You have the server side, which is the back end, and then the client side, which is the front end. Now, applications are tiered. Web applications especially are multi-tiered. You have the top tier or the client tier, which is the user interface, the browser, right? Then we have the business logic tier. This business logic tier is actually where your code resides on the web server. And then you have the bottom tier, which is actually the database. So essentially, web applications are structured or they have three components, three-tier components. The browser, which is the top tier, and then the server essentially handles the business logic, and then the data layer, which is the database. So this is how your web application is stored. For the front end, you're essentially dealing with the browser. Everything that has to do with the client side or the front end is being handled by the browser, and it is the top tier. While the server side has to do with the business logic and then the bottom layer, which is the database. So the client side handles the web server and database. Well, we're going to look into that by the time we start the Django development. Okay, so this is how the web applications are being tiered. Then we're going to look at another important concept known as the model view controller. This is actually a pattern of web development. MVC stands for model view controller. It is actually a pattern or an architecture of how the web works. The model essentially refers to the data, right? The data in your application, things like your database schema, your actual database, which can be hosted on another server. Then the view layer is actually what gets rendered to the client. So if you make a request to a website, the view is what you see, is the template you see as a response, while the controller are just some functions in the server that controls the logic. They are the ones that intercept every request and then sends you a view. So essentially, that is what the model view controller is, just a web architecture pattern. If you're building a website, you have to understand the concept of model view controller. It helps you structure your application in a professional way. It's actually an industry standard. So every web application goes through this process. You have your data layer, which is the model. You have your view, which is the template that people see when they make requests. Then the controller is your business logic, is the functions, the method, the classes you have, the things that the programs, statements you have on your server that actually intercept requests. Sometimes the controller make requests to the database to get information and then sends it to the view for presentation, right? So essentially, that's what the MVC frame pattern stands for. Now, data exchange. Like I said, there are different kinds of data exchange in web development. When a user makes requests to the server, one of the formats of extending data is HTML, which is a template. But that's not all. We have other forms of templates like JSON. JSON means JavaScript Object Notation. The JSON essentially is a JavaScript-based object format, for sending data. This is typically done when you're writing API endpoints. We'll get to that when we start Django development properly. So you can structure an application in such a way that it sends in JSON data, not templates, not HTML. You can make a request to a particular endpoint, and then you get data back, just raw data in form of JSON. Then another format of data is the YAML. YAML stands for YAML is YAML. It's just another markup language. So these are all data exchange formats: XML, HTML, JSON, YAML, because the server can handle all of these kind of data formats. Now, let's quickly move on to endpoints. An endpoint is a specific URL or URLs, right, within a RESTful API. So, for example, when I do www.facebook.com/username, that is an endpoint, is a URL. So you're trying to make a request with a URL. So when you typically hear REST APIs, when you hear endpoints, it's just simply a URL or a URI that represent a resources. So when you make such request, you're requesting for a particular resource on the web. Now, there are key characteristics of an endpoint. One is HTTP. An endpoint has an HTTP method. It can be get, post, or delete. A get method is a request to a server to get a particular resource, while a post method is a request to the same server to send in data. For example, you want to submit a form. It has a post method, a post request to an endpoint. So endpoints can support a get request. Let's say you're requesting for a list of blog posts. It has a post method that makes requests to the server to send information, typically when you're filling a form, where you're trying to sign into your account. Then you have a put method. The put method updates a particular information on the server, in the database via the server. So put is another method. Then we have the delete. The delete method to a particular endpoint helps you to delete a particular resource on the server. So these are the four methods, HTTP method, that can be used in a particular endpoint: the get method, the put method, the post method, and then the delete method. Beyond this, there are certain protocols that we must obey, like HTTPS and all of those things. Then there's another concept known as CRUD operation. It's similar to the HTTP web method we just defined. CRUD stands for create, read, update, delete. You can read more on this. The create method is synonymous to your post method. It's used to create a particular resource on a data. It's used to create data or record on the database, right? The read operation helps you to get information from the database. The update helps you to update information in the database, while the delete helps you to delete information on the database. So in web development, these are essentially most of the things we do. Most of the web applications you're going to be building with Django essentially are going to be CRUD operations. One, you have to create data at the back end. You have to read data, get the list of information you need from the database, update records from the database, delete records. So essentially, your task is CRUD operations. These are the things you're going to be doing in web development. So it's important to understand how all of these things fit together. Now, lastly, we're going to talk about Django. before we move on, do you have any question?
For me, none at the moment.
Okay. So let's talk about Django. Django, we've discussed briefly about libraries and framework. So Django is essentially a web framework for perfectionists with deadline. That's their tagline. As you can see on their website, Django makes it easier to build better web apps more quickly and then with less code. Django is a free open source web framework written in Python programming language, and it's used by millions of programmers every year. It is popular. Its popularity is due to its friendliness and for beginners and both advanced programmers. So Django actually is beginner friendly, and then it is opinionated. What it means by being opinionated is it defines a lot of things for you as a beginner. You don't have to think too much. It makes a lot of decisions for you on how to structure your application, how to build your application, what needs to be done. Unlike other lightweight frameworks like Express, Ruby on Rails, Flask, Django is essentially it is a robust framework. It's usually known as batteries included framework. So you do not have to do many of the installations with other packages. It comes pre-built with a lot of features such as authentication, templating, admin interface, security support, pretty much all the things that you would need to build a web application. Django comes built in with it. So that's why they normally call it a battery included web framework. Though some people believe it has it has a steep learning curve, but of course, all of these things depend on how you attempt to solve to learn Django in the first place. Okay, so that is that about what Django is. Like I said, it provides common support for common tasks in web development. It's easy to learn. It's powerful and flexible enough to grow with your needs. Its batteries included. I've already said that. Django powers a lot of websites, thousands of websites on the internet. Websites like Instagram were built with Django, Pinterest, Bitbucket, Discourse. These are all websites that have been built with Django. So if you essentially want to build a fast web application without stress, Django is the right way to go, and that's why we're going to be using Django. Of course, there are other frameworks available out there like Flask, Fast API, but Django is the #1 framework when it comes to Python for web development. Okay, so let's move on. So how does Django works? So Django, initially we discussed about the MVC frameworks, the model view and the controller. Now Django essentially does not follow that pattern. Django uses an MVT framework. It's called a model template and view, MTV, model template and view. So it's actually a bit different from the MVC framework. So I'm going to explain Django MVT framework, model, view, and template. So for the data layer, Django uses model, of course. So the model, actually, the M there is the model. The MVT, the M there is the model. The model essentially is the data structure. It handles everything between the database, right? So if you're building an application, for example, you want to build a contact application or a customer management application, you need to have a way to store your data. But before you even store your data, you need to define your data. Now, we discussed about class in the previous session. By the time we begin Django properly, you will now see why classes are important and what classes help us to do. You can't build any serious web application without using classes. And Django has some built-in classes we have to extend, by creating our own classes. So you must define the structure of your data. So your model in your MVT is your data structure, how your data is going to be arranged in the database, what type of fields are going to be in the database. These are all the things regarding your model, right? Then you talk about the view. The view is the second layer of your template. The view is what communicates with the database, right? So, and then it is what transfers data to the template. Now, the view is just like the middleman, right? You have your database, you have your model, you've defined your model, your schemas, how your data is going to be represented, you've created your database. All of that is handled by the view. The next component is all of that is handled by the model. The model handles your data, your database, your data schema, your data structure. Everything about your data and how it's being stored is going to be handled by your model, right? Then the view is the agent, is the middle guy that communicates with your database, right? When a request is coming from the client, when the user types your website address, the view is what essentially handles that request, intercepts that request, talks to the database for some record or some information, and then send back information back to the client, either through template or through JSON or through XML, whatever format, data exchange format. The view can handle all of that. And what is a view? A view is simply a class or even a function. A view can be a function or a class in your program. We're going to look at all of how to create Django views using classes and functions as we by the time we start writing Django projects, right? Then the third layer is the template. The template is what the user sees. So when I make a request from a client, it hits my view. My view intercepts that request through the URL endpoint. How do I make a request? Through the URL endpoint, we've discussed that. Then the view intercepts that endpoint, checks to see what you're requesting for, handles the request, and then communicate to the database if there is any need for that, and then returns back a template. So the MVT, the T there is the template, which is the presentation layer. Django uses a plain text template system that keeps everything that the browser renders, right? Django can also send JSON. Remember, when you're dealing with APIs, Django sends JSON data, right? But when you're dealing with a traditional web application, Django can send HTML back to the client in form of a template. So the templating engine is essentially HTML that has some logic in it, okay? So Django architecture, okay? Let's quickly discuss Django architecture. So Django processes request and response circle through different components. First is the URL, views, model, and template. So let me quickly explain how Django architecture works. If you look at this diagram, you can see from your web browser, you make an HTTP request, usually with an endpoint, that is a URL. Then there's something called a URL dispatcher in Django project. This is URL dispatcher is what is like a mapping of all the URLs that an application has. So if I make a request to the home page, the application itself, the Django app knows exactly that there is a request that is going to come from that to a home page. If you make a request to an about page, the application knows. So the URL dispatcher has a list of all the URLs that a web application has. Okay, so when you make a request that a web application does not have, you typically get a response that says 404, which means page not found. But typically, the URL dispatcher handles all the requests coming from the web browser. Now, it sends the request back to the view, right? So the view is a function or a class in your Django application that handles a request through the URL dispatcher. Now, sometimes the view talks to the model, talks to your model. Maybe it has to get data from the database. The view communicates to your database, gets the information, filter it if need be, perform certain processing. So views are very powerful. They are like the middle guys. They, aside from reaching out to database, they also perform other operations. They can perform, or you can write sub operations in your view that, like your business logic, for instance. Okay. Now, once the view communicates to the model, it reaches out to the database. The database sends back a request back to the view, and then the view now sends it back to the template, right? Then the template is being rendered as a response to the web browser. Then the user now sees the web browser. So essentially, this is the flow from web browser to the URL dispatcher to the view, from the view to the model, from the model communicates to the database. The database sends information back to the view. The view processes that information, filter, delete, query, do all sorts of stuff, and then sends a response back in form of a template. Now, this template can also be a JSON data, remember. Then it sends it back to the web browser, and then the user now sees a particular web browser. So this is how Django processes, Django architecture essentially works. Now, when starting a Django application, there are certain commands like start project commands that you need to know, for the sake of, actually we're supposed to install a fresh instance of Django, but we're not going to do that. We're going to start that in our next class, installing a Django project and then writing all of this command. But let me just give a brief overview of all of the Django, the basic Django commands that you need to be familiar with. So we need to familiarize ourselves with all of these commands. First is Django admin start project. Django admin start project, I'll tell you what it does. It's a command that you typically enter in the terminal. So this command, essentially what it does is that it helps you to start a brand new instance of a Django project. So you have to specify the project name and then use this command. Okay, then next is Python manage.py run server. So if you want to run your project on your local server, Python manage.py run server is the command you need to enter. You don't need to cram or memorize any of these things. I'm just giving us an overview. As you keep writing Python, as you keep building Python projects, as time goes on, these things begin to stick in your head. You don't even need to memorize them. Okay. So the run server command actually helps you to create, to start a Django development server, while the Django admin start project creates a new Django project with a specific name. Number 3, we have Python manage.py start app. Now I'm going to tell us, in a Django application, we have things known as applications. Now, applications, you can think about them as a sub-component of your entire project. I'm going to talk about difference between a project and an app very, very soon after this. So the Python manage.py start app name is a command that helps you to create an instance of an app. Okay. Then next we have Python manage.py migrate. Usually this is done when when you make changes to your model. Make migration actually creates a migration on your database, right? Then the migrate actually migrates the information to your database. The make migration actually initialize the migration, while the migrate command actually creates the migration. So you can think about the make migration as the command that tries to check to create an instance of the migration before running the actual migration. We'll look into that deeply as we begin to write Python a Django project. Then we also have another command that says Python manage.py create super user. Now, this function actually helps you to create a super admin in your Django application. Like I said, Django is a batteries included web framework. It comes with a built-in admin interface for you to use and manage your data. So once you start a Django project, you can actually run the create user command for you to create a super user in the admin interface. Okay. Then lastly, we have Python manage.py test app. So this command, essentially what it does is when you're writing your project, you need to run some tests, right? So, and typically you run unit tests. Unit tests are being executed in an app. Django has a project structure for project in such a way that you create reusable components like apps inside your Django project. So inside those apps, you can actually build tests. There's a file known as for running tests in your Django application. So you can use this command, Python manage.py test, then the app name to actually run your test to see if your application is working properly. These are all industry standard. When you're building an application, you must run unit and integrated tests. And we're going to look at all of these things when we begin to build projects. So to recap, we have the start project command, we have the run server command, we have the start app command, the migrate, make migration commands, create super user command, and then the test happening command. All of these commands are some of the basic, these are like the basic commands you typically run when you start your application. So let me quickly talk about Django project and app structure. This is not the real project structure yet. This is just a way for us to see how Django is being structured using when you start a project and then creating reusable apps under your project. So if you look at this diagram, you can see that you have a Django project. A Django project is considered as an installation of Django with some settings. So at the top level, you have a Django project. When you run that Django admin start project, you actually create an instance of a Django project with some setting files and basic configuration, right? Now, an application is different, right? So applications are actually inside your Django project. Think about an app. Let's say you have a website that has a blog. A blog can be a separate app in your website. Think about maybe your website having a forum, right? A forum can be an app. Think about your website having an order tracking system, like an e-commerce system where you add product to cart, maybe like a store. That store can be like an app, is a sub-component of your website. Let's say you're trying to log in users, create account for users. That is known as authentication. That authentication system is known as an app. You can create an app for just authenticating users, like allowing users to sign up and sign in. So that is how a Django project is being structured. You create a project, then you create different apps under the project. Apps like blogs, authentication, let's say forum, or you create pages, static pages. These are all built together. These things come together to make up your website, right? So all of these things come together. Let's say you also want to create, for example, a record in the database where you can store customers, a CRM, for example. You can create a separate app for a CRM, so that app interacts with other apps in your Django website as a whole. So your project is structured in such a way that you have different reusable apps, and then you have under your one main project. And then your app can actually, you can actually source for apps from third-party websites. By the time we start development, we will see Django packages. There's a website known as Django packages where you can see some reusable apps to use in your project. Okay, let's say you want to run certain functionalities. Sometimes you don't have to reinvent the wheel. If there's a package on an app, a Django app in existence, you can quickly import that app into your project, and then you can just add some settings and then use straight away. So Django gives you that flexibility. So essentially, you build different apps inside your Django project. Apps like blog, forum, CRM, pages to handle all of your static pages, authentication. These are all apps inside your Django project. And these apps essentially interact with one another. Okay? So with that, I think we've come to the end of today's class. If you have any question, you can quickly drop in from what we've discussed before we move on. Any question?
Yeah, my name is Dominic. Can you hear me?
Yeah, Dominic.
Yeah, so you said a lot of things about Django and how apps are structured and all that. So do you just sit down and then just decide that you are going to put this particular app there, you are going to involve authentication, you are going to display the page like this?
Sorry, I'm not hearing you clearly.
Just give me a minute. Let me switch to. Can you hear me now?
Yes, better.
Okay. So you spoke about components and designs and all that. I will start with downloading components from other Django projects. How do we determine how safe those components are before involving them in our app project or app? Because there could be, the developer could input backdoors and all that in his code. So how do we determine how safe the code is before integrating it into our own design? That's one. Then the second one is, in terms of design, right? In terms of system design, how do we design the system from the design thinking point of view, right? What are the requirements? What are the things we should consider in terms of design? Because from what I'm getting now, in our next class, we should start working with Django, like hands-on with Django. But if we don't really know what is required for us to design a very good system in terms of backend, then we're going to have difficulties designing not just a very good functional system, but also a very secure system.
Okay. So to answer your question, the first question is how do we know if a package is safe, right? So
yes,
this is, if you can see my screen, this is Django packages. Django packages is a directory of reusable apps, sites, tools, and more for your Django project. So if you navigate through those websites, for example, you can use frameworks, other people's projects, as you can see. But let's go to apps. If you go to apps, you will see a lot of reusable apps. For example, look at this. This is Django REST framework. We're going to be using this also in time to come. Django REST framework is a package for making for building API endpoints, right? So one of the ways you can see most of the package listed here, some are actually old. And how do you know if a package is safe? First, you look at the GitHub stars, right? There are usually popular packages on GitHub. So if you want to see, first you have to check if the package or the app is under active development. When last was the last commit made to the project, you know, and what are the number of stars? How many contributors does the project has? You know, so these are all the metrics you can use to know. And in the Django ecosystem, there are certain packages that has a lot of contributors that are industry, like they are among the top 20 packages that people are actively working on because they are so vital in your Django development. For example, if you want to do authentication, right, there's something called Django Alert. This Django REST framework is one of the top 2 packages in the Django ecosystem. So you can see, if you go to GitHub, you can see the number of stars it has. So one, check the number of stars, check the number of contributors, check the last time it was updated, right? And then the number of people using the package. These are how you get to know if it's safe. Something that has not been contributed or that has not been updated for years, you know it's a no-go area, right? Then you see this other one, Django Allot. These are other very popular packages. So over time, as you get experience, you begin to know that there are certain packages that you must use because a lot of contributors are working on it and they are very, very experienced. So I don't know if I'm able to answer your questions. You can filter through all of this list if you want to do e-commerce. There are certain packages. Then when you go to GitHub, there's something called Awesome Django. It's a repository that shows you a lot of packages that are actually in active development, right? And you can pick from all of that. Then 2, talking about design systems. Talking about design system in Django, I think if I get your question clearly, how do you build design system? How do you begin to actually start building a Django project, right? Okay. So
Yes.
essentially what I've just done is I've just give you a background on what Django is and how it's been structured. Now, we are going to do a live demo installing Django and then creating our project directory. But all what I've told you is part of the Django workflow. It has an MVT framework. It uses URLs, it uses models, it uses views and templates. So you will see everything fitting together by the time you begin to build application. You will know how to define URL routings. You understand the project structure, what each of your files are doing. Once we've done the installation, I'll explain everything, what every file is doing in a Django project and what every folder is doing in a Django project. I'm going to explain everything. I think that will give you a better understanding on how everything fits together or the design system you're talking about. Okay. Then by the time we begin to build individual apps, you will start seeing that there are some repetitions, right? Every app has certain kind of folders. What are those folders? What are those files? What are they doing? So I'll explain all of those things by the time we do a brand new installation of a Django project. And then we're going to start doing a project-based learning. We're going to be building either a blog application in the next class, or we'll build a noteboard application, push to a live deployment, do testing, send to GitHub repo. So these are all the things we're going to be doing. And I'll explain how everything fits together so that you really understand if you're building a Django project, these are the things, these are the components, these are how it works under the hood. Now, you don't need to cram or memorize anything. The more you build a project, the more it begins to resonate. Just know what each folder is doing, each file, how to structure them, and how to call your classes. So that's how it's going to work. I don't know if I'm able to answer your question, okay? If I'm not, maybe you make it more clearer.
You answered it, but there are a few things that you probably, maybe I wasn't clear enough, so you did not touch on them. So let me paint you a picture. If you, for front end, right, the UI UX designer gives you a design, right, that you now interpret. That's develop as a front end developer. For back end, the business logic and all that, right, has to be interpreted in terms of, or designed in terms of code before the developer will start interpreting that design, that's building the blocks or the models that will later be put together to form the app. Now, in terms of that design, right, how do we go about it? Or is it not our responsibility as back-end developers to think and then put that design in place?
Sorry, please come again, sorry. I think I'm getting what you're saying now, but I missed you at some point, the network.
Okay, so for front-end developers, they don't really have to design because the UI UX designer gives them the design that they interpret, right? For back-end developers, the business logic, and all that, do we do it ourselves? And if we do it ourselves, what are the requirements? What are the bases? Because you know that, okay, I have to design, I have to handle users. These users have to be authenticated. These users' access have to be determined, right? Identification, and then authentication, and then access control, authorization has to be done for these users. All that, is it done when you sit on the system, you just write a bunch of code, or you already design it out, and then you say, okay, these are the blocks, or these are the modules that I need to build, and then this is how these modules connect together.
Okay, powerful, very good, very, very. And now I think I understand the question now. So essentially, what I need to, let me explain. For front-end development, yes, UI UX guys design the interface from their user research, they pass it over to the front-end guys, they code it. Now for backend, what we essentially do, there's something called software development processes. I think that is what, if I understand what you're saying, that's what it is. Now, the software development process can be agile, right? It usually should be agile. So it's a process where first you get, I think it's the 5 to 7 stage, process where you get your user requirements. First, you need to understand what are the software requirements. What am I trying to create? What problem am I trying to solve? Let's say you're trying to build an e-commerce solution. You need to know, okay, fine, if I'm building an e-commerce or a CRM, for example, I need to find a way to store customer record. I need to have an interface where I'll create a customer, probably delete a customer, send a customer a message. So usually those information are gotten from your customers, your clients. So if you have a software development project, you sit down with your customers to define requirements. What is your app supposed to do? What problem are you trying to solve? Now, once you have all the requirements in the project, then you begin to design. There's also a concept known as software design, at the back end, where you now begin to define your classes. That's your schema, your data schema, and then the relationship between your data. So for an e-commerce application, you need to have a cart system. Users have to add items to carts. Then a user can actually have the relationship between an order system. So because when users can make order, so there has to be a connection in database between users and the order system, the ordering system, right? There has to be a relationship between the users and the tracking system. Then you have the product schema. That in itself can be defined, right? The product schema is just the relationship between the records, the product records in your database. Then you can have stock inventory. So all of these things are how you now begin to design your project, right? The software, the relationship it has, the number of functions, what some functions are going to be doing, what classes are going to be doing, structuring. Django in itself provides you with built-in classes and functions for all of these things, right? All you need to do is to design your software requirements, design your database schema. The database schema is just basically structuring your data using classes, right? What are the relationship between your data? And then relationships can be in different from one to many, many to one. All of those things we'll get to see as we begin to build this project. But to answer your question, there has to be a software requirement, right? That document is what will outline the things, the functionalities of your website, the data, the models, the functionalities, all the user classes is going to be contained in the software requirements document. Then from there, you can now begin to flesh out all of those requirements step by step using either a flowchart or a database schema, whatever you choose to intend to use. Then you can now start the actual software development, the coding process, writing the code. Now, once you're done with that, the next stage is to test your application. Then you test, you debug, right? Then you iterate. You can even deploy. Once you deploy, then you iterate again. Because most of the times you have to work with clients to continue to change features, updates, and all of that. So that is how the architecture work. That's how the processes work, when it comes to software development.
Thank you.
You're welcome. So any other question?
Yes, sir. As my question I was asking initially was, you were explaining about class, right? And
Yes, sir.
you are saying more details about the class. If you are defining a class in a programming, for example, like a car, you have to specify some specific things like the brand, the color, and some other things, which you call, I think, initiatives, right?
Yes.
So before you come to that stage, you put a statement called pass that it avoids error. It helps you avoid error. So when you are defining that class with those initiatives, are you going to include that pass statement after the initiative you define them, or are you just going to ignore it? That is my question.
Okay. Okay. Fine. Fantastic. Actually, the reason why I defined, to answer your question, no, you don't have to always put in pass. Even in functions, pass is a keyword in Python. It works for functions. I can define a function. When you write a function, for example, you have the function head and then you have the function body. That is the blocks of code that you want to be executed when you invoke the function, right? Before you put in any statement in the function that should be executed, you can just put in pass. So pass is just like a keyword in Python that allows you to define a function or a class without adding anything in the body. Normally, if you don't put in pass, it will throw an error because the compiler or interpreter expects you to put in, for functions, it expects you to write in at least one or two statements inside the code block. So if you're not ready to write any statement in a function block, you can just put in pass keyword just to tell the interpreter that, okay, I'm going to continue with this function later. I just want to define it, just define the name. Similarly with class, the reason why I put in pass is because I'm not yet ready to put in class methods or use the init function the init method to initialize the properties of the class. But if you notice, when I started initializing the properties of the class, I removed the pass keyword. So you can just use the pass keyword as a placeholder each time you define a class or a function, and then you're not yet ready to pass in other information, because defining a class like that without the init method or without the class methods and variables will throw an error. So the pass is just a placeholder to temporarily hold, ensure that the class doesn't throw an error. Meanwhile, you're coming back to update the class when you're defining it. So that's essentially what it does.
Okay, sir. Thank you very much. Then the second question I want to ask is, I have come across this website developments, but using cPanel and WordPress. So how is it? How am I going to compare it with this backend web development program? Or how different? What's the difference? Or what is the similarities? Or what's the difference? I'm just a kind of confused.
Okay. For web development with Django, actually, let me start by saying there are different ways you can build a web application or a website. Typically, there's a difference between a website and a web application. A website, for me, is just maybe static pages. Let's say you build an informational website that has just a name about the company, contact, and all of those things. Typically, I call that static websites. But a web application is something that people can come and interact with. Like Facebook is a web application, right? When you have things like authentication, like people logging in and logging out, have record on the database, do stuff, perform action on your website, typically is a web application. Okay, so WordPress can also be a web application and it can be a static website. The difference is just the technology. WordPress is powered by PHP, and WordPress is a content management system. It just helps you build a website using drag and drop interface, okay, and templates and plugins. So WordPress allows you, is a content management system that allows you to quickly build a website with templates, page builders, and plugins. Plugins helps you with functionalities like logging, But if you understand PHP programming, you can actually customize WordPress. But Django, backend development, is still building website and web application. But now we are using a different technology, not PHP, not WordPress. We are using Python and a web framework called Django. So building a web application with Django gives you a lot of flexibility. You can decide to build on any idea you have, okay? No limitations, because you know how to code it, you know how to customize it, you know how to build from scratch. And typically, when you want to work in a startup or you want to work in a company, they prefer you have custom knowledge of building web application, not just WordPress. Okay, so the difference essentially is in the programming language and the tools we use to build these websites. But you can also build web applications with Python, with WordPress, using PHP. Okay.
Okay. Like e-commerce website, right?
Yes, you can build an e-commerce website with WordPress.
So
essentially, there are plugins. There are plugins that, the truth is, it's not like you're writing this thing code by yourself. There are already plugins that has all of those functionalities for you. Like if you want to book, like order a product, add to cart, payment, even payment, you can have a plugin that does it. But the beauty of it, of using things like Python and Django, is you write these things yourself, so you are in charge of how the workflow is, how the processes go. Okay, so Django allows you to customize, to build your own startup ideas. It's just powerful, and it gives you a lot of flexibility. There's a friend of mine that called me last week. He wants to build a platform where you can have lesson teachers and parents can come on the platform. He's a WordPress developer, but he cannot build that kind of a platform because he doesn't know how to write code, because he doesn't know Django. So he had to reach out to me and ask me. I told him, yes, I can build it. So that's the beauty. There are limitations anyway, because you don't know how the programming language works, so you cannot go and customize for different functionalities. You have to rely on third-party plugins. And sometimes these plugins are buggy, they have security issues, they might not work properly. But in all, it is possible. Okay?
Yeah, thank you very much, sir.
You're welcome. So, any more questions? So, in the absence of question, next week we are going to be starting everything we're going to be doing now will be Django development. We're going to be looking at installing Django on our local machine. I'm going to send us some resource and an assignment on GitHub, hopefully by Monday. Then that's tomorrow. So by next week, we're going to start installation of Django. We're going to explain what the project folder is, how Django really works, so that you don't get confused when you see a Django app. You can literally open any Django project you see and understand how it's being structured and what is going on. Okay. Then we're also going to create virtual environment. There's something called virtual environment so that your applications, your software will not clash with other versions of software you have on your system. We're going to be seeing how to build an app, so a website. It's going to start with the basic one, like a blog, how to manage posts in the blog from the admin interface. We're also going to see how to quickly deploy a Django project, how to integrate Git and GitHub, push our project. All of the things we'll be having an overview on, we're going to be seeing them practically with Django in our next class. So please, let's have our laptops charged close to us, because we're really going to be, I encourage us to actually hold along as I actually build these projects so that we can learn. It's actually learn by doing. You can't just learn by sitting down. Then all of the fundamentals we've learned about Python. If you notice, we just went, I have the materials I'm going to send to us, but you can take time this week to actually go over some of those fundamentals, understand what classes are deeply, understand what functions are, and how we use them, especially functions and classes. Once you have a good grasp of them, then it will be easy for you to work with Django, because Django essentially is just Python, okay? But they have certain things built in for us so that we can build a web application easily, okay? So thank you very much, guys, for your time. See you guys next week.
Okay. Thank you very much.
Yeah.